It changes how humans relate to one another. It changes how kingdoms are built, how kingdoms are torn down. It changes colonization.
Number 10, gunpowder, 9th century. This has to be one of the most ironic discoveries in history. Chinese alchemists were experimenting with life-lengthening elixirs, with the ultimate goal of finding eternal life.
Instead, what they created was a flammable powder that burned down many of their homes. They quickly realized that this black powder, which they called fire medicine, was precisely the opposite of something that would make you live forever.
For centuries, potassium nitrate, also known as saltpeter, had been a staple in medical compounds. When one alchemist mixed saltpeter with sulfur and charcoal, the mysterious powder brought about explosive results.
Gunpowder changed the style of wars. The Steel Age ended, and gunpowder-based weapons are now widely used.
The substance led to burned hands and faces, and the structure they were working in burns to the ground. What was supposed to be the elixir for immortality was soon weaponized, ultimately leading to the ending of countless lives throughout history.
We, as a species, had so much fear and created so much mythology around the concept of thunder and lightning. In the gun, you have brought that kind of fear, that kind of primal fear, and placed it in the hands of an individual.
Number 9, natural radioactivity, 1896. We can thank storm clouds for this discovery. French scientist Henri Becquerel was experimenting with uranium crystals during a sunny day.
For his experiments, Becquerel took uranium salts, conditioned them so that they became highly fluorescent, and looked to see if the photographic paper reacted, as with X-rays. And, lo and behold, it worked.
He believed that sunlight shining through uranium salts could burn images onto photographic plates. As storm clouds rolled in, Becquerel packed up his supplies to continue the experiment on another sunny day. A few days later, he unpacked his supplies from a drawer and found that the salts had burned a shadow onto the plate even without the sun's help.
He soon realized that the sample had given off some type of radiation without being stimulated to do so by the sunlight. These Becquerel rays were similar to X-rays in their ability to penetrate paper, which was opaque to visible light.
While Becquerel discovered natural radioactivity, the phenomenon would not receive a name until Pierre and Marie Curie coined it.
She and Pierre calculated the energy that spontaneously flowed from a lump of radium would be much greater than burning the same amount of coal. Radioactivity, to their astonishment, was millions of times more potent than chemical energy.
Number 8, smart dust, aka neural dust, 2003. Graduate school brought about this revolutionary discovery. During her program at the University of California, San Diego, student Jamie Link was working on a silicon chip in an attempt to produce a sort of film on a crystalline layer. The chip shattered during her work, but instead of scrapping the project and starting over, Link investigated the shattered pieces of the chip. She realized that the tiny bits were still sending signals and acting as small sensors. The self-assembling particles earned the moniker smart dust, and with good reason. They have the potential to revolutionize medicine. Sometimes broken things can be very beautiful.
It has many uses. It's like tiny sensors. The tiny particles can be programmed to detect substances, like toxins in the environment, or they can be used in medical diagnoses.
Number 7, Viagra, 1992.
Sometimes the best way to get closer is to get as far away from it all as possible. Don't let erectile dysfunction get in the way.
This was definitely what you would call a happy accident. Viagra, which then went by the less sexy name UK92-480, was initially developed by Pfizer to treat angina, or chest pain caused by reduced blood flow to the heart.
But its trials in humans were a letdown. It was about to be consigned back to the stores when the trial volunteers started coming back and reporting an unusual side effect.
During the clinical trial for the new medicine, male participants reported a sizable improvement in a different area. Apparently, the pill helped blood flow to other parts of the body. Unfortunately, the drug did little to treat angina, but its unexpected side effects addressed another issue.
It wasn't that the drug didn't work. It did relax blood vessels by blocking a specific chemical process in the body. It's just that that process wasn't happening in the heart.
Once it got a name change and a new PR spin, the little blue pill became a goldmine.
Isn't it time you talk to your doctor about Viagra? 20 million men already have.
Number 6, vulcanization, 1893.
Vulcanization is the process by which rubber is transformed so that it is no longer susceptible to heat or cold, and this was Goodyear's great discovery.
The tires on vehicles that safely carry us are actually the result of an accident. While rubber had been used for years for waterproof shoes, most people did not see much potential beyond footwear. However, scientist Charles Goodyear disagreed. He experimented to make rubber more durable and expand its uses, but his best discovery was a complete accident. In the midst of showing off his newest composite, he dropped it on a hot stove. Once it cooled and was removed from the stove, Goodyear realized the rubber was much stronger than before. The accident had weatherproofed the rubber, and the process of vulcanization was discovered.
He lost his fortune several times, went bankrupt a number of times, but never gave up on the idea, this is something that will change the world, and he was absolutely right.
The Goodyear Tire and Rubber Company we still know today was later named after Charles Goodyear himself.
Serious freedom.
Only from Goodyear.
Goodyear.
Number 5, X-rays, 1895. No bones about it, this discovery is pretty amazing. Physicist and Professor Wilhelm Röntgen was conducting an experiment to see if cathode rays could pass through glass. During the experiment, an odd green light actually projected onto a fluorescent screen nearby. Even though the cathode tube was covered, Röntgen investigated further and discovered that while the light could pass through most substances, including human skin, it couldn't penetrate through others, including human bone. The accidental discovery earned Röntgen the first ever Nobel Prize in Physics and completely changed how physicians diagnosed bone fractures and other issues.
The publication of the silhouettes and the first exposure of a hand had a sensational effect on the general public.
Number 4, Teflon, 1938. That's right, your perfect omelets or blueberry muffins were the result of an accident. Chemist Roy Plunkett was trying to develop a new, safer refrigerant in New Jersey. He and his assistant were experimenting with a chemical formula known as tetrafluoroethylene, TFE. He froze about 100 pressurized tanks of the substance, but when one was opened, no gas came out. Upon further inspection, Plunkett discovered that the experimental gas had transformed into a white waxy powder.
The pressure and temperature had created a new substance.
The powder, of course, could not be used as a refrigerant, but it was highly resistant to heat and corrosion and had low surface friction.
Plunkett discovered that Teflon stood up to corrosive chemicals. That's why one of its initial uses was on the project to build the first atomic bomb.
Once the substance coated cookware, despite its now controversial reputation, it made flippin' flapjacks and creating cakes as easy as pie.
Did somebody say pie? It's a wonderful day for pie. You can ask all the birds in the sky.
Number 3, medical anesthesia, 1844. What was once simply an unsavory party drug turned out to have lasting effects on the world of dentistry. Before the mid-1800s, nitrous oxide, or laughing gas, was used recreationally. In 1844, dentist Horace Wells attended a demonstration of nitric oxide and noticed that an apothecary clerk who was showing off the party drug hurt his leg while under the influence. Afterwards, Wells asked the clerk if his leg hurt, and the clerk admitted he hadn't even noticed the injury. Wells went on to experiment with laughing gas, first on himself and then on several of his patients in dental surgeries. He realized his theory was right. Nitrous oxide makes it so that people couldn't feel pain. Thus, the medical world was forever changed. Number 2, microwave ovens, 1945. If engineer Percy Spencer hadn't kept a chocolate bar in his pocket at work, we might not have ever gotten the magic of microwavable pizza rolls. When Spencer was working with a radar machine at the U.S. firm Raytheon, he noticed that the chocolate bar in his pocket was melting very quickly. He figured the melting must have to do with the microwave radio signals and set about experimenting with food and an electromagnetic field generator in the hopes of speeding up cooking. After much experimentation, his company released the first commercial microwave oven and changed the lives of hungry, busy, and lazy people everywhere. Number 1. Penicillin, 1928.
The most minor injuries could be deadly. And then a discovery was made that changed the world.
Alexander Fleming showed us that taking a break can be good for your work, and even save lives. The Scottish scientist was in the middle of studying bacteria when he suspended his endeavors to leave on vacation with his family. When he returned, one of his batches had been contaminated with fungus, which actually killed the bacteria.
What Fleming stumbled upon was a microbial defense system. The Penicillium mold constantly produces penicillin in order to defend itself from threats, such as nearby bacterial colonies that might consume its resources.
When Fleming isolated the fungus in a pure culture of bacteria, he found that the so-called mold juice was effective against the bacteria that caused pneumonia, scarlet fever, meningitis, and other diseases. After more experimentation and a much-needed name change, a pure compound of penicillin was produced, and modern medicine got a crucial upgrade.
Fleming published what he had done, calling his substance penicillin. Attempts to purify it and to extract its essence failed.
Do you agree with our picks? Check out this other recent clip from WatchMojo, and be sure to subscribe and ring the bell to be notified about our latest videos.